Hello, my name is Rylan Phipps, and today I'm going to be presenting a residential humidifier analysis for AME 430 Project 4. Before I get into the presentation, here is just a quick overview of the topics that we will be discussing. For the introduction, now we're going to talk about why we are doing this humidifier analysis, and the first one is to develop an understanding of how humidifiers work. The second major one is to develop an understanding of the importance of humidifiers. One thing to note is that humidifiers can create a healthier environment in dry conditions, and it can also help reduce the temperature of the air within a room by having more humidity in it. Another thing is also it can help reduce allergies if there's more humidity in the air as well. So for this analysis, we had to choose a residential humidifier, and I chose the Homedics Fireside Ultrasonic Humidifier, and this is actually the exact same one that I have in my room, so I figured why not do the analysis with this. So as you can see, the cost is $79.99. The water tank size is about a third of a gallon. The maximum runtime is around 11 hours, and the total power is 27 watts. In order to do the analysis, we need to choose a climate, and I chose to choose Tucson, Arizona, which is where I live. Also choose the month of April, which is when this recording was taken. The average temperature is around 68.1 degrees Fahrenheit with a relative humidity of 27%. So the humidity ratio we can use using this psychrometric chart right here. And so what we want to do is we know the dry bulb temperature, which is 68.1 degrees. We draw a straight vertical line here. And then we want to use the 27% humidity, and basically it is right here, so we mark that right there. The intersection of these two lines is what we want, and we draw a straight horizontal line all the way over to the right side, and we get a value of 0.004 for the humidity ratio. So the first part of this analysis is to find the mass flow rate of the humidifier. We know the water tank capacity and we know the pounds per gallon of water. Simply multiply those two together to get 2.4186 pounds, and so that's the total mass of the water that we have. The maximum runtime is around 11 hours, so we get 39,600 seconds. And using the mass flow rate equation, we have found that the mass flow rate for the humidifier is 6.1075 times 10 to the 7 pounds per second. So here's a simplified version of a humidifier diagram. And so one thing to note is that the atmospheric pressure throughout the whole entire analysis will be considered 1 atmosphere. We also want the inlet and the liquid water in the tank temperature to be about 72 degrees, which is room temp, which is what I keep my house at in April. And here we also wanted to convert watts into BTUs per second, so this is a value here. And so going in, we have moist air at T1, room temperature, and we have the humidity ratio at 0.1, 0.004, and we also have the mass flow rate. We also have the liquid water being injected into the control volume at m.3 mass rate. We also have an enthalpy 3. We also have no heat transfer in or out of the control volume, so that is equal to 0. The work is equal to the 27 watts going in, and coming out is the second temperature. All right, so now on to the second part of the analysis. So what we're going to do is we want to find m.1, assuming omega 2 equals 1.3 omega 1, which 1.3 is about 30% higher. So what's that saying is that omega 2 over here is going to be about 30% higher than what it is going into it. And so we just did a simple mass rate balances for the dry air and the water as seen here. And then using the definition of the humidity ratio, which is mass flow rate of water over the mass flow rate of air, dry air, you can find the mass flow rate of water as such. And then using the mass flow rate of the dry air with this humidity ratio, we can actually find the mass of the air, or m.A, and then plugging in the values, which we have already found previously, we can get this value for the mass of the air, or the mass flow rate of the air. The next step is using the mass flow rate of the moist air into the humidifier. And this can be seen here, and then plugging in the value that we found up here for the mass flow rate of the dry air, we can actually find m dot 1, which is about 5.1099 times 10 to the negative 2 pounds per second. The third and final step of our analysis is we want to find the outlet temperature, or T2, coming out of the humidifier. So to do that, we're going to use the energy rate balance equation, the generalized form here. And so using the assumptions of steady state and negligible kinetic and potential energy changes, as well as it being an adiabatic process, we can simplify it relatively down to this simple equation right here. Utilizing the mass flow rate of the water from the previous slide, we put that into this equation here. We simplify things, and also we want to isolate the specific enthalpy on this side, and doing so results in this equation that we will be using in the next few slides. So we need to find some values in order to solve for the temperature using the equation on the previous slide all the way at the bottom. So the first one is H3, or the enthalpy at state 3, and this is just a simple table lookup with A2E with the temperature. Then we use a psychometric table. So we know W1 is 0.004, or omega 1, so we draw a straight horizontal line. And then we also know that T1 is 72 degrees Fahrenheit, so we draw a vertical line right here. And so where omega and T intersect, we want to take that spot and draw a line about 45-degree angle all the way up to here to get the specific enthalpy of moist air at state 1, which is 21.6 BTU per pound. Alright, so using this equation that we got from a few slides ago, plugging in all the variables that we found, we get a value of 21.1438 for the specific enthalpy of moist air at state 2. And so using the psychometric table, we can use this information to help solve for the temperature. So we know the humidity ratio at state 2 is 0.0052, so we draw a straight line. We find this value correlated on the graph, which is here. We draw this straight line where these two graphs meet. We draw a straight vertical line, straight down, and that gives us a temperature of 64 degrees Fahrenheit for our temperature coming out of the humidifier. Alright, so in summary, we learned that humidifiers are used to create healthier environments, especially with allergies, which is useful in Tucson in the springtime. We now have a deeper understanding of the physics of humidifiers, and from the analysis, we performed it in a dry environment. And the mass flow rate of 5.1099 times 10 to the negative 2 is needed to increase the humidity ratio by 30% coming out of the humidifier. And then finally, we used the energy rate balance, and that was found to be that it cooled the air down to 64 degrees from an inlet temperature of 72. And so that is it for this presentation. I hope you learned some things about humidifiers, and I hope you enjoyed watching it. Thank you very much.